Today we are going to create the design for our gliders. Yesterday we looked at how gliders work. We were able to get a glider to fly, but today we are going to start by setting the materials that we will be working with. Whenever we are using a flight simulator, we want to make sure, or any sort of a simulator, computer generated simulation, we want to ensure that what we're inputting in the program matches what we actually have in person. So the first thing that we're going to do today is set our materials to the exact materials that I have available. Only then can we actually design a glider that will fly. Hopefully we can get one to fly again. Alex, I hope your internet does not get lost because you were really good with it yesterday. So hopefully you can stay on. All right.
Thanks.
How does this program work? It told us yesterday that it can fly, but where is it getting its information from? I want you to think back to what equations have we seen so far that help us calculate anything related to flying. Unmute and tell me what equations have we been working with so far.
Coefficient of lift.
Coefficient of lift. While you're unmuted, Justin, what is included in the coefficient of lift?
Wing area, velocity, air pressure, and regular lift.
Good. Well, how do we get that information in this simulator? The coefficient of lift is supposed to tell us how much lift do we have, and vice versa. If we know the coefficient of lift, we can also figure out what is the amount of lift that the aircraft can produce. Do we have that information anywhere in this program? We better, because how else is it able to tell us that this glider will actually fly? If you guys recall from yesterday, underneath the wing tab, we have a velocity setting. We can change our velocity to either launch with less velocity or launched with more velocity. Which one of the velocity options is going to produce more lift? Do I want less velocity or more velocity if I want more lift?
More velocity.
More velocity, absolutely, Alex. The more velocity I have, the more lift it would produce. However, you guys will be launching these gliders with your hand. If I said that my glider is going to fly with 40 kilometers per hour, that's really not very accurate. So while more velocity is going to help for the program to tell us, yes, your glider will fly, we need to keep it realistic as well. I say, let's go ahead and keep the velocity to 20 kilometers per hour. This is what we used yesterday. If we're able to launch the glider with higher speed than that, that's only going to improve the flight. But let's not have velocity more than 20. The other components that we said would be included in the formula for lift is the area of the wing. Well, I'm pretty sure this program should be able to calculate the area of the wing. If we have a root chord, we have a taper ratio that we can adjust, it can calculate. We have a span for the wings. It can certainly calculate what is the overall area of the wing. The other component was air density. Is there anything here about air density, you think? I'm going to click, can you all please take a look at Zoom? I'm going to click on File and then Edit Configuration. And restart the program because it stopped working. All right, let's see if that will work. I'm gonna try to open it twice. All right, this is silly, but it worked in my other screen. All right. So when I go under edit configuration, I have several settings that could be changed. I can change the name of the configuration, meaning what type of settings are there, and I can save them for next time to reuse. But I also have density. I have density for the air, standard air density right here. I also have density for the materials that we will be using. Because remember that the lift is a reactive force to the weight. So I really need to know how much does this glider weigh? Not just what is the area of the wing, but how much does it weigh? In order for that to happen, we are going to actually measure out a few of the balsa wood pieces that I have, and we're going to fill in some average dimensions on here. So I want you to please take a minute and look through the screen in terms of information that we need as I grab a ruler and move my camera over. All right, let's see. Ethan, could you tell me something that you see on this configuration?
Yes, this is a nose mask.
The nose mask could be included on here. The maximum nose mass, meaning how much clay am I willing to give you when I send you the materials? At the most, I am willing to give you 20 grams, so I am going to decrease that. I'm not giving you more than that, 20 grams. Sam, could you tell me something else that you're seeing on the configuration settings?
Max wing width.
The wing width is represented by the chord. What is the maximum chord that we have? Okay. All right, let me clarify something on here. The left column, all of those max wingspan, max wing width, wing thickness, wing density. Every one of these components is relating to the material that we're going to use for the wings. We are using balsa wood for our wings. And I am giving each one of you exactly one piece of balsa wood. So we have to fill out our dimensions on here. I did not grab anything to measure the thickness of the wing, but I do know it's supposed to be 1/8 of an inch. So we'll be able to relate that. I want you to please note that every one of these dimensions are given in metric units, and this is how we're keeping them. In order for this to work, we have to use the actual maximum wingspan. Remember that from the settings yesterday, we had an option of saying just use one piece of wood. We're going to make sure that as we build the glider today, we have that setting on. All right, I am going to switch my camera to using my iPad. I have a meter stick, and we are going to actually measure out a few of these pieces so that we can get the actual dimensions. All right. The balsa wood that you guys are receiving has dimensions of, according to this label, 1/8 inch by 3 inches by 36 inches. We need to get those dimensions in centimeters, and of course we can convert that, or we can just measure it this way.
Miss Gallo, where are we recording all this?
You're not. You're helping me to do it, unfortunately.
Oh, okay.
I have to do it as a demonstration.
I was confused. I thought we were gonna like put into the app, but we didn't have the app.
Yeah, right. You guys don't have the app, unfortunately. It only works on Windows. It's very easy to install if you have a Windows device. So if you have any sort of a computer where you can install, it's very easy to install. And I have the link provided for you in yesterday's folder. but otherwise you don't have access to it. So we're taking the measurements and you guys are going to help me to fill them out in the app here. Once we have the specific dimensions put into the app, you guys are going to help me to get a glider that flies. Once we have a glider that flies, I am printing those dimensions, and these are the dimensions that you will be receiving to build your glider with. Make sense?
Yep.
I appreciate you asking me because I'm sure you were not the only person who was confused. The 36 inches, I'm measuring on the meter stick right here. And on the meter stick, 36 inches are equivalent to 912 millimeters. So as I go over to my screen again, I need to set the actual span of the wing to 912 millimeters. In centimeters, it is 91.1. Note that it is less than what the original dimensions were. So the glider that we might have designed yesterday, you cannot build because you would run out of material. The maximum wing width, it was 3 inches. I am going to measure that width. When I measure it using the ruler, I get 7.4 centimeters. I'm verifying that measurement, 7.4 centimeters. The next thing is the wing thickness. Can somebody please use Google and check what is the equivalent of 1/8 inches? What is the equivalent of 1/8 inches in centimeters? Ethan, would you like to do that conversion for me?
Sure.
What is the equivalence of 1/8 inch into centimeters?
I got 0.32 centimeters.
Sorry, say that one more time.
0.32 centimeters.
Okay, perfect. So that thickness was already the correct thickness. Now the next thing says, what is the wing density? How in the world am I going to find the density of a wing? How do I measure the density of this wing? Any suggestion?
Wouldn't it be the density of the wood?
Yeah, but it doesn't say it on the label. So what do I do?
You take the weight and not the surface area, the, what's it called? Volume.
Good. Now, for the volume, I need to know the length, the width, and the thickness. We just put those in, right? Which means the program can now calculate the volume of this piece of wood. But it needs to know its weight. Absolutely, Alex. We need to know the weight. So what are we going to do? We're going to measure what is the weight of this component. I have to stop sharing for a minute. I am going to switch over to the camera from my other device. If you would all please go ahead and take a look at Zoom. There we go. Can you guys? Do you guys hear me?
Yes.
Yeah. For you.
Okay, no feedback. Okay, good. Make sure you're not in gallery view. Maybe go over to active speaker view so that you can be seeing the measurement right here. Okay, so I have one piece of wing. We're going to put that on a scale. My scale is in grams. Let me switch my camera. All right, what do we see for the measurement?
41 grams.
All right, this was this piece of wing. How about I grab a different one? Same size, right? It's not clipped in any way. Let's take a look. Is this the same weight?
No.
Like not at all, right? 27 grams versus 41 grams. That's quite a big difference. Let me grab another piece. A random piece, whatever. It's the same piece, right? Same thickness, same dimensions. Is it the same weight?
No.
Nope. Another piece. Is it the same weight?
No.
All right. So how in the world are we going to get that density? Am I going to calculate that separately for each one of you? You think? Not that nice. What we are going to do is put a few of these pieces. Do you guys see how I have 5 of those pieces? 5, you see that? We are going to weigh 5 or 10 of them together, and we're going to divide this value by 5. So one of you please do the math. 176 divided by 5. That way we are getting an average value. 176 divided by 5. Somebody
I
please
got
do the math.
35.2.
I guess I have to stay on here for a second longer. 35.2.
Yep.
Ben, can you write that number somewhere, please? I want to be able to. Can you write that number down somewhere? 35.2, right?
Yeah.
Okay, just write it down somewhere.
Okay.
This is the material that we're using for the fuselage, right here. We're gonna get the dimensions in a minute, but let's go ahead and weigh it while I have the scale on here. So I'm putting one piece of the fuselage. The weight comes up as 12. Let's see, is this a little bit more consistent? The wings are made out of balsa wood. The fuselage is made out of basswood. Look at this. 13 versus 12 gram, not bad. Next one is 14 gram. These are still pretty consistent, right? With the balsa wood, we saw a lot of variety. Balsa wood is not very consistent in density. So with balsa wood, it is really, really important that we average our density. Basswood is a lot more consistent. We get 12, 12, 13, 14, 14. We can go ahead and average this out. I certainly could put all 5 again and divide this by 5. This will give me 13 grams. Okay. Great. Let's switch over to the other computer. Why are we doing all this? Because we need to know what is the actual density of the materials that we are using. All right, Ben, do you still remember your numbers?
I remember 35.2.
Okay, 35.2. We're using this to calculate the wing density. And it actually tells you in the program, enter the mass of the entire wing piece of wood in grams. We're gonna say okay, and it calculates the volume, and we have put in the weight so that it can calculate what is the wing density. We got 163.17. Let me do that one more time. 35.2 grams Okay, it calculated the correct density for us. The next thing that we have to input is the dimensions of the fuselage. Once again, where we'll be calculating the wing density, or not wing, but the fuselage density. And the average weight for the fuselage piece was 13 grams. So I'm going to input that. The max fuselage length, well, I have to measure this piece. This piece is exactly 60.8 centimeters. The width of the fuselage is 0.45. The depth of the fuselage, the side of the fuselage, is can I see it on this? Not inches, centimeters, Ms. Gallo. 0.9 or 0.95 actually would be more accurate, 0.95. Now that I have the right length, I am going to calculate the density one more time for the fuselage. All right, let me hear from Jacob, James, or Hannah, actually, any one of the three of you. Why are we inputting these settings? Jacob, James, or Hannah, why are we inputting all these settings?
So we can find the glider.
Say that again, Hannah.
So we can find our total weight of the glider.
Exactly. We need to have that so that we represent the materials that we're using and the program can calculate what is the actual weight of the glider. The last setting that we might want to consider replacing on here is the airfoil coefficient of lift. The airfoil coefficient of lift is going to have a lesser value than what we have right now. I am going to leave it as is. But really, if you do not take the time to sand down an airfoil shape of your wing, you will not have such a high coefficient of lift value as what the program is currently using. Please keep that in mind. All right, now that we have our configuration and I hit OK, the maximum fuselage length that I can select is 60.8 centimeters. The maximum for the wing is showing up as 91.1. But I have to keep in mind that I need to only use one piece of wood. And now it is limiting what is the maximum width, all of my dimensions are limited so that you can build the glider with these two pieces of wood and nothing else. All right. Now I need your guys' help to build a designer or to design a glider that will fly. Yesterday, you did it pretty quickly. Today, we could try two different options. Our option number one is that we build or design a standard glider. A standard glider is going to have the wings forward, horizontal stabilizer and vertical stabilizer are in the back. Yesterday, I showed you that a lot of my students actually choose to build a glider that has the horizontal stabilizer to the front. This is called a canard style glider. And if you guys want, you can try to get a canard style glider instead of the standard. So let's take a quick vote. Which type of glider do you prefer to create? Do you prefer, what type of glider do you want to design? You can either vote for standard or canard style. Canard style means canard style means that you are going to put the horizontal stabilizer ahead of the wings. There should be a poll that showed up for you. Go ahead and answer those questions, please, or this one question. Oh, where's Logan to vote for canard? You guys are boring with your standard style.
I don't trust myself enough to build a fancy one.
All right, well, I was able to convince at least 2 people to vote for canard. Nonetheless, the standard one is definitely beating right now with 75% vote for standard and 25% for canard. So standard it is. No worries, we can do standard. All right, let's go ahead and try to get a glider that flies. As soon as we have a glider that flies, I can print those plans and they will be ready for you guys to build. Let's go in order. Sam, what suggestion do you have for changes on that glider? Let's start with the fuselage, actually, Sam. Do you want to keep the fuselage with full length, or would you like to shorten that big stick for the fuselage?
I would like to shorten it.
What measurement would you like for it to have?
40.03.
Let's keep it simple, 40. I like 40. I have to say, you guys are building this at home. You do not have a ruler with the exact measurement of 40 most likely, because most of them go up to 30 for the standard ruler. So I'm good with 40, keep it longer. That's totally okay. All right, the next dimension, wing location. Justin, what do you want to do with the wing location?
Let's say like 22.
22?
No, let's move it some more. How about 18?
I like that better.
There we go.
Yeah, I like that better. All right, the next one, Alex, what do you want to do with the stabilizer location? Stabilizer, remember,
The
is your
stabilizer, the
horizontal.
vertical or the horizontal?
Horizontal. When they just say
Horizontal.
stabilizer, it's the horizontal. Yeah.
Keep it there, make it smaller.
You make it smaller. Okay, so I'm going to move
Yeah.
over to stabilizer and I'm going to make it smaller. Do you want me to change the span, the root cord? In which way do you want me to make it smaller?
Thinner.
Thinner? Is that the span
Yeah.
or the root cord?
That would be span. No, root cord. Root cord.
Root cord. Good. That would be the root cord. How much thinner do you want it?
A little bit thinner than that.
4.5 centimeters?
Yeah, let's go with 4.5.
Okay. Now that I've made it thinner, do you want me to push the stabilizer back?
Definitely.
All the way back?
Yeah.
All right. Thank you. Jacob, you're next. What would you like to do with the vertical stabilizer? The vertical stabilizer, remember, right now is shown with this purple line. That's what we see right now. Jacob, do you want to keep it there? Do you want to make any changes to it?
I think that would be fine.
Keep it where it is?
Yeah.
All right. James, you are next. Nose mass. Do you want to keep it at 8 grams?
Yeah, it sounds good.
Sounds good?
Maybe a little less.
Less? Sure, I'll give you 6 grams. You got it. Let me see who's next. Hannah, are you there?
Yes.
All right, I'm gonna move over to the wing tab, okay? For the wing tab, do you want to make any changes?
Thinner and add a taper.
If you want it thinner, what am I changing? The root cord or the span?
The root cord.
Can I just give you an idea? Okay. Yes, I like the idea of having a thinner wing. Are you guys seeing my camera?
Yes.
Please make sure you find my camera. Okay? This is a piece of wood you will receive. If you want to make the wing thinner, not only, so first you're gonna make it shorter. So let's say this is the span of your wing. If you want to make it thinner, then you have to cut all this across. Are you sure you want to deal with that? No, you
Absolutely
don't want to.
not.
No, don't do that. If you were here and you had a long meter stick or something, you know, I could maybe cut it for you in the laser cutter or something. Sure. But if you're doing it at home, keep it simple, okay? Keep the thickness of the wing as it is. That way, you do not have to cut all the way across. If you want to add a taper, so that you cut 2 triangular pieces, that would be easier to do. But if you wanted to make it thinner all the way, that will be just too much work. So Hannah, I'm sorry, I'm gonna turn your suggestion down. It's a wonderful suggestion. Having those thinner wings would be okay, but honestly, keep the area bigger and keep your life simpler.
Okay.
Make sense?
Yes.
All right, so we're going to keep the root cord the same. Would you like to do anything with the span? Would you like to do anything with taper?
Yes, you should
Leading
taper
edge.
it a little bit.
You do what?
We should taper it a little bit.
All right, I'm gonna change to what number? Point, anything between 0 and 1.
0.7.
Yes?
Sure.
All right. After Hannah, I'm seeing Sam, but I already talked to Sam, I thought. Ben. I did not hear from you. Ben,
Yes.
do you want to make any other changes to the wing?
I don't think so.
I'm good with that.
Okay.
I'm good with that. Who have I not heard from? Ethan, have I heard from you?
I don't know. I think I told you the nose mask.
Okay, I heard from Jacob, I heard from Alex. Looks like I heard from everybody. All right. The one thing that I would also caution you, if you keep the vertical tail, like right now, look at the vertical tail, this purple line is wider than your horizontal stabilizer, right? How are you going to attach that? Because like the vertical stabilizer rests on top of currently the horizontal stabilizer. You would have to cut out a little piece for the thickness of the horizontal stabilizer, which is okay, you can do it, but you don't want to have a hole in the front. You don't want to leave that hanging as a hole because it is going to cause for more drag to be created. So do you guys want to make any changes to the vertical stabilizer?
We can make it a little shorter, maybe.
Make it shorter?
That's what I was thinking. Like make it like even with the horizontal stabilizer,
Yeah.
so
Okay.
it's not like stretching out past it.
Okay, if you don't want it to be stretching out past it, then we would be changing the root cord. The root cord of the horizontal stabilizer was 4.5. We can make the same root cord for the vertical stabilizer, 4.5. Now when I go back to my main tab, I think I need to do something with this vertical stabilizer. What do you guys think?
You gotta move it back.
I want to move it back, so I'm going to move it all the way back if I would like for it to match. And now they are the same width.
Now it's looking pretty.
Okay, our vertical tail right now is really tall, 13.67 centimeters tall. If you guys are seeing my camera, 13.67 is like half of my face. Do you want to keep it this high, or would you like to make it shorter?
Make it shorter.
Ben, how much shorter?
like a lot shorter. Like, I don't know, maybe 5,
5 centimeters?
or is that too short?
Let's try. I think we're ready to test out our glider. This is the current design. Let's see if it will fly. I'm gonna do file. Analysis, will it fly? Nope, it doesn't fly. However, we get some feedback. It says the vertical tail is incorrectly placed or sized. And it says you should consider increasing the area of the vertical tail or move it further aft. Do any of you know what further aft means? Further back. Aft is a term in aviation and aeronaut and what is it called when you're and oh my goodness, when you're on a ship, what is that called? Not aeronautics. Well, it's a term that is used on ships and airplanes. Let's just leave it at that. It also says that the stabilizer might be larger than necessary. So we need to make some changes. Make your suggestions and I'll make the changes. Alex, you were good with that yesterday. Jump in.
What?
The glider isn't flying. What changes do we want to make?
We want to make it fly.
Yes.
Yeah.
So just
Make the wings bigger.
Well, look at our
I
suggestions.
think we
Our
got to do
suggestions
something
were-
about the vertical stabilizer.
Our suggestions were the vertical tail is incorrectly placed or sized. It tells us to move the vertical stabilizer further back. We don't have any space to put it further back. It's all
Let's
the way
make it
in.
Make
bigger
the
then.
fuselage bigger.
Or we can make its area bigger, or we can change the stabilizer. It says the horizontal stabilizer might be larger than necessary. So what do we want to do? What do you
Make it
guys
smaller.
make? What smaller?
The
Alex?
vertical stabilizer.
Smaller?
Yeah.
Okay, go ahead.
Oh, that's really small.
Exactly. It's already pretty small. Mhm.
Yeah, I don't know what's up with that.
Do you want to make it bigger? That increase its area.
Put it at like 6, probably
7.
7.
File
second
or
guess.
analysis, will it fly? No, it's not gonna fly.
God dang it.
Our number,
maybe we should move the wings
Got
up a little bit.
okay,
Doesn't seem very balanced.
okay. Alex, where do you want to move the wings? You got it.
Forward.
Forward. So right now they're at 18 centimeters from the top. You want to move them at 16, like that, or more?
Let's say like 15.
15. Let's
Yeah,
try.
that looks
That's
good.
3. Look at that. He just made one change and it will fly.
Yes, sir.
Alex is like the king of the gliders. Officially, you are getting that title, Alex.
Yeah, that plane's gonna fly nice.
Now it does say that, no, yesterday, remember, we did not have any suggestions. This one, we still have some suggestions. It still says that the stabilizer might be larger than necessary. It says that the static margin for stability, remember in the PowerPoint yesterday, we explored that a glider really needs to be stable in all directions. Right now, the static margin for stability is less than the recommended value. So it says it's going to fly, but it's probably not going to be flying very smoothly. So let's make some changes. It says the stabilizer might be larger than necessary. So let's make the stabilizer smaller. I'm going to wait for specific suggestions.
The horizontal stabilizer?
Oh yeah, we gotta like
Yeah,
make it
it's
more
pretty
skinny.
wide. The span. Pretty big span.
That is pretty big, yeah. What do we want to change it to?
Like 23.
23? Do any of you have a ruler handy? 23 centimeters is still really big.
Let's make it 14.
What did I do? Yeah.
What, 14? Do we want to try Justin's 14?
I don't know.
Let's
Maybe.
try it. Analysis, will it fly? No, right now it says the center of gravity is behind the neutral point. The weight is not distributed properly. So let's go
You
back
gotta move the
to,
wings back a little bit.
okay. Oh, I was gonna make the stabilizer a little bit bigger again. No, it says too big. What did you say, to move the wings back? Alex?
Yeah, because I mean the stabilizer was too small.
Sorry,
Why
the
not?
wing, we said move back. So what, at
Yeah,
how many centimeters?
17.
Analysis, will it fly? The king of gliders, like seriously. We do still have a suggestion right underneath. It still says the stabilizer might be larger than necessary. Do we want to make any changes to the stabilizer? Sam, what do you think? Ethan, what do you think? James, what do you think?
Yeah, Sam's the pilot here. He should be helping us out. Me and Alex don't know what we're talking about.
Mm.
Sam, what do you think?
I think that sometimes you just have to let the stabilizer be and just let it do what it wants to do.
Do you want to leave it like that, or do you want to
Never let Sam fly a plane.
Let's just see what happens. I say let's just let it be.
just let it be?
Let's just let it be.
Let's try it
Sam,
again.
I think that's a lazy answer.
I agree. I agree. You said it though. Let's try it with a little bit smaller. It still says it's too big. Do we want to do a taper on the stabilizer?
No. No.
It's like, nope, that's too much work. I'm gonna have to cut this out. Good
Yeah.
call.
Let's
Good
just
call.
make the stabilizer a little smaller.
16.
What is it right now? 18? Let's make it like 16.5. And then we'll move.
Perfect. I made it 16.
Wait,
And
and it's
we
not giving
no
us any
longer have that
recommendations.
suggestion. We just have perfect dimensions. Well done, you guys.
That means perfect flight.
That means perfect, hopefully. We will see. The perfect flight is going to depend on how well you are going to be able to put your glider together. Now that I have found a glider that flies, I didn't, you guys did. But now that we have found a glider that flies, we want to save that glider. So I'm gonna call it a class glider 2020. And I'm going to print those plans. What I would like for you to do now, please, is open Schoology, and under Tuesday, I put the plans from yesterday. I want you to please take a minute and look over the PDF document. There are 4 pages, and let me know if you have any questions on the plans. So Justin, great question. How exactly are you going to achieve the taper of your wings? Keep in mind, you actually use the tapered wing for your glider that you guys will be building. So you really need to know this, okay? The first thing you're going to do is measure out the span of your wing. So if your wing was 55 centimeters long, first you're going to cut it to 55 centimeters,
What?
cut that out. The next thing you're going to do is measure out the midpoint of your wing. So whatever the span was, you're going to divide that by 2 and measure out the midpoint of the wing. In the plans, if you go to page number 2, it shows you what is the chord right in the midpoint, 7 centimeters. This should be your actual span of the wing. You're not cutting it right in the midpoint. At the end point, it is going to be exactly 5.6 centimeters. Based off of the taper on page 2, you will be able to see, please take a look at the camera. You will be able to see what is the chord of the wing at the very end. You're going to mark that point, and then you're going to connect the midpoints that you marked with the end point measurement. And then you have to cut out this piece. Make sense, Justin? Sort of?
Sorry, what'd you say?
Does it make sense?
Yeah, it does.
Okay. And I will try to also describe that in the discussion, because this is a really important component on how you will do it. Any other questions? Jacob,
Okay.
what questions do you have? Jacob, what questions do you have?
Trying to think of one.
I will ask you, on the plans, where do I find the vertical stabilizer size and dimensions? Ethan, same question. On the plans, where do I find the dimensions and size for the vertical stabilizer?
Find them on the third page.
On the third page. Please note that they're also using arrows to show you where's the front facing. Be very careful with those arrows when you guys are building your glider. Make sure you pay attention to which side is supposed to be facing the front. Good. Alex, Ben, any questions?
I don't think I have any.
I
Okay.
think
Not
this
right
is a
now.
question. I know like on other gliders you said that we use some of the clay to put on the wing tips to weigh those down a little bit. Are we going to do that, or is it all for the nose?
It does not all have to be for the nose. I'm going to try to weigh out about 20 grams of clay, although I might get lazy and just eyeball how much clay I'm giving you. Any
Yeah.
leftover clay, you are more than welcome to place some on the wings so that you can achieve balance for the wings.
All right.
Will
thank
we
you.
need like a a scale or something?
Well, no, not really. Not really.
Okay.
It says that you should have 8 grams of clay. I'm not going to send you just with 8 grams of clay. I want to make sure that you have some extra.
right.
What you are going to do is actually balance the glider on your finger, and you will continue adding mass to the front of the glider until you see that your glider is balanced on the center of gravity.
Okay.
James, Sam, any questions?
Seems good to me.
Who was that? Oh, James. Okay.
No, I don't have any questions.
All right, Sam. Let me go ahead and pause my recording.